The universe is full of mysteries. Black holes warp space and time, galaxies collide in spectacular displays of energy. But here on Earth, a different kind of mystery has captivated our imagination: the quest to create artificial intelligence. For decades, scientists have dreamed of building machines that can think like us. Machines that can learn, reason, and solve problems. With OpenAI's 0-1 model, that dream takes a giant leap forward. The 0-1 model isn't just another incremental improvement in AI, it represents a fundamental shift in how we approach machine intelligence. In the past, AI systems were primarily trained on massive datasets, learning to identify patterns and make predictions based on statistical probabilities. These systems excelled at tasks like image recognition and natural language processing, but they often struggled with tasks requiring complex reasoning or logical deduction. The 0-1 model takes a different approach. It's designed to think like a human, building chains of logical reasoning to arrive at conclusions. Imagine a detective piecing together clues at a crime scene. That's the kind of reasoning power the 0-1 model brings to the table. It's a new era of AI, one where machines don't just crunch numbers, they think for themselves. This breakthrough has the potential to revolutionize countless fields. From medicine to finance to scientific research, the ability to analyze information and draw logical conclusions is essential. With the 0-1 model, we're on the cusp of unlocking a new era of innovation, one where AI systems work alongside humans to solve some of the world's most pressing challenges. The human mind is a remarkable instrument. We effortlessly navigate complex social interactions, solve abstract puzzles, and build intricate theories about the world around us. At the heart of this cognitive prowess lies our ability to reason logically. We can take a set of facts, apply rules of inference, and arrive at new, valid conclusions. This process of deduction is fundamental to human intelligence. Traditional AI systems, however, have struggled to replicate this kind of logical reasoning. They've been more akin to parrots, mimicking patterns in data without truly understanding the underlying relationships. The 0-1 model breaks free from this limitation. It's trained not just on data, but on the very principles of logic and reasoning. Imagine teaching a child to play chess. You wouldn't just show them thousands of games and expect them to learn by osmosis. You teach them the rules, the strategies, the logical underpinnings of the game. That's how the 0-1 model is trained. It learns the rules of logic, the principles of deduction, the art of constructing valid arguments. This focus on correct reasoning represents a paradigm shift in AI training. Instead of simply learning to predict the most likely outcome, the 0-1 model learns to reason its way to the most logically sound conclusion. It's a move away from statistical probability and towards the elegance of pure logic. This new approach holds the key to unlocking a deeper, more profound level of artificial intelligence. In today's digital age, information is abundant. We are constantly bombarded with data from every direction. Navigating this sea of information can be overwhelming. Artificial intelligence, or AI, steps in as a powerful tool to help us make sense of it all. By analyzing vast amounts of data, AI can identify patterns and insights that would be impossible for humans to discern on their own. Despite its impressive capabilities, the traditional 0-1 model of AI has its limitations. It struggles with tasks that require understanding context or making nuanced decisions. This model operates in a binary fashion, which can be too rigid for the complexities of real-world scenarios. As a result, there is a growing need for more advanced AI systems that can think and reason more like humans. Enter the new era of reasoning machines. These advanced AI systems are designed to mimic human thought processes, allowing them to tackle more complex and abstract problems. By integrating sophisticated algorithms and vast amounts of data, these machines can understand context, learn from experience, and make more informed decisions. This marks a significant leap forward in the evolution of AI, opening up new possibilities for innovation and problem solving.